Hey guys, hope all of you are very excited because I definitely am. And good evening, good afternoon, good morning to wherever you're coming from, wherever you're tuning in, because there are blockchain enthusiasts all around the world, and we have something for all of you today. So, at my side, I am first, let me introduce myself. So, I'm Sanskar. I am a content marketer at HackerRank and currently an intern, but hopefully I'll get a PPO if the manager really likes my life. So I want all of you to drop a lot of comments because you have to get me the job now. And by my side, I have Lucas, who is a senior software engineer at Meta. And today he's the one who's going to be teaching us how to make a smart contract. So let's start with the live stream. But first, let me introduce him properly. So by day, Lucas Hendren is a senior software engineer at Meta, and by night, he's an avid Web3 and blockchain enthusiast and builder. Lucas has had an illustrious career so far, having previously worked at Alphabet's Verily and CapitalOne, and his roles have been wide ranging: a researcher, a tech lead, a co founder and CTO, and an engineer. His latest endeavor is an exciting Web3 solution called Permigrade. But you know what's the most exciting thing about him? He's actually a crypto veteran. He's seen Bitcoin grow from being an obscure concept in 2013 to now even your uncle talking about it on dinner. Fun fact, Lucas discovered Ether where it was priced at just $30, but decided not to buy it because he thought it was expensive then. So if he would have bought a lot of quantities then we would not have had him here teaching us about smart contracts. So I'm kind of happy that you did not buy the Ether, but we are very excited to have you here, Lucas, and congratulations on becoming a Hacker Rank All Star.
Yeah, thanks. And yeah, to clarify, I got in it. There was and we'll probably touch base on this briefly. There was the a big event called the Dow Hack, and I actually got in slightly after that, but I used that to fuel some private startups I was working on at the time, which didn't pan out, but that's how life is sometimes. But
Okay.
yeah, glad to be here.
So, do you wish that you would have bought a lot then? Like, how much do you regret it? I would love to know.
I don't regret the ether part because, like I said, I did get in. There is a big hack called the Dow Hack that happened right around the $20 to $30 range, and it went back down to $5 or $6. So I got in then, used that to fuel some private startups, which, like I said, didn't work out, but that's how it goes sometimes. There's probably bigger regret for 2013. Got into Bitcoin then, was using it to heat my family house. We were in Colorado, which has very large winters. Sadly, we sold in 2014. I'd say that's where I have the regret. Selling in 2014 was regretful.
Okay. But I hope that all of our viewers are enjoying this. And if you're a blockchain enthusiast and you're currently in the live stream, I want all of you to put in your city name so that we can see wherever the blockchain enthusiasts are coming from. So if you're from India, you can post the city of India that you're from. If you're from the US, then you can post the city that you're from, and we'll publish it on the screen here so that Lucas can also see that blockchain enthusiasts all around the world have joined in to watch him today. So right. Lucas, now I think it's a good time to start with the live stream. Have a lot of people here. We have a lot of people joining in, and they are very excited. We have someone from Trichy, uh, which is a city in India. We have someone from Chennai streaming in. We have someone from Dubai streaming in, and I hope you are having a lot of fun. Okay, we have a lot of these coming in. We have someone from Philadelphia as well. Welcome, Lexi. We have someone from Bangalore, from India. And there are people from all around the world, as you can see. We have someone from, right? So I think this is a good time to start with the live stream. I hope all of you are extremely excited for it. So let's start. So, Lucas, to start things off, could you tell us about your experience with blockchain development and also someone who has followed this space for 8 years now? What are your thoughts on it gaining so much traction? Like you can hear everyone around you talking about it. So, how do you feel about it?
Sure. So kind of getting started with to answer the first part for my experience in blockchain development. Kevin's previously mentioned started mining in 2013, 2014. At that point, wasn't really developing so much, but heard about Bitcoin and blockchain technology. Thought it was interesting, and exciting. So kind of set up some mining rigs, started heating our family house in Colorado. ended up my parents also got in on it, and we probably kind of got rid of all my furniture in my room, so it was just kind of a mattress and some computer servers for a bit there. But you get used to the loud hum pretty quickly, and we were making a lot of Bitcoin, so it was okay. But after that, kind of set back for a bit, but then went to work for CapitalOne in 2015, and that's when I ended up kind of becoming their blockchain, a tech lead for their blockchain rapid prototyping team. And so that's when I really got into the development of it. That's when I also really got into Ethereum and some of the other non-Bitcoin-esque blockchains. So sort of did that for a year and a half. Ended up competing in some hackathons, winning. I got into an incubator called Boost VC, which is pretty big in Silicon Valley and has had a lot of early blockchain companies come through. Did that, ended up forming my own company. While doing that too, I was contributing to Ethereum and some open source projects. Company was moderately successful, and we're using blockchain technology to help healthcare entities share data for analytics. We had some issues with COVID, so ended up not carrying forward. But yeah, that was probably my biggest thing in blockchain. Continue to contribute in open source though outside of that, and I'm working on some new projects now, specifically using Arweave along with some other blockchain networks to fuel some perma-web solutions. As for my thoughts, at the space gaining so much traction, generally speaking, excited and happy about it. I'll say I find that usually the space, it's probably never at the right level of excitement. It's usually always, doom and gloom or, probably way too much excitement. It's never probably at the right amount. But in general, compared to where things were in 2012 and 2013, where when I tried to explain to family members why I don't have any furniture and just computer servers mining stuff, it's nice for them not to look at me like I'm a madman. They still look at me like I'm slightly insane, but like it's no longer like, oh, you're crazy trading these Mario coins. Like, oh, this makes more sense now. We still think you're a little bit out there, but it's nice not to be. It's nice to be validated, I guess.
I mean, like, if your relatives think about or hear about Bitcoin now, they would have the first thought that would come into their mind was Lucas used to do this before, and then we invalidated him. But see, this concept has grown so much, and it feels good, like something like this has gaining so much traction because people might not believe in Bitcoin or Ethereum or cryptocurrency in general, but blockchain is here to stay. Right, blockchain is a concept that has been utilized in so many different areas. So that's what we are here for. So
Yeah.
which takes me right. So which takes me to the next question. Because blockchain and Web3, I feel and I believe everyone here believes that it will stay. So what are a few languages, frameworks, and platforms that are a must learn for building in the blockchain and this Web3 space?
Sure. So, it's a still a very new industry, so there's stuff popping up every day. So it can be hard to catch up. I'd say in general, learning the basics are good. Framework wise and tool wise, I think some of the best things to probably learn is, just kind of learn how Bitcoin works and operates, how to interact with it. There's several popular libraries. One specifically I'll be going over, and this is called Web3. For Node, that's a good one to learn. It's good to learn Ethereum and Solidity. They're kind of the two most popular ones. But outside of that, there's a ton of other platforms that are good to learn too, like Solana and Cardano, which is probably good to start with the most popular ones because a lot of the stuff they did is kind of the basis for the projects.
Mhm.
I would say though, probably the biggest thing would probably be learning would probably be reading the white papers of the network, specifically the technical papers. You can kind of read through the documentation, learn how to interact with them, but to really learn the capabilities of the network and what they bring to the table, that sort of thing. It's really good to actually take your time, read through the technical white paper and that sort of thing, or just any technical documentation explaining how things work. And, you may not understand all of it right away, but if you read the paper, then you start looking through the stuff you don't understand and Googling or researching that, and then you come back to the white paper. I think that will give you the best understanding of the network.
Yeah,
Um,
reading
Yep.
documentation is very stressful for developers. Like they do not want to go there. They want to like figure everything out by trial and error. But you brought up a great point that everyone should first go through the white paper and understand how it works, and then employ it, right?
Yeah, correct. There's a lot of like theory here, so and kind of just more algorithm-based stuff. So it's a bit harder to just like you can still kind of utilize it, but you won't get the full capabilities if you don't actually
Hmm.
understand, what's going on behind the scenes.
Right. So we have a very interesting question here. You're speaking about mining. So a question has come up from Kapil who asks, can you give a brief about mining and how your computers are used for data mining? I
Sh-
mean, I think he was Bitcoin mining, but yeah.
yeah, sure. So basically with a blockchain network, as I'll get into here too in a little bit, the basic idea is you have a distributed ledger or distributed system, and there's a few different varieties, but at the base, for the most basic one, with the proof of work thing, with the proof of work model, the computer servers are basically, when I say they're mining, they're realistically doing something. They're basically computing this very hard math problem. They're
Mhm.
validating the block they're going to add, and they're computing a very hard math problem to add it to the chain. And they're all doing it at once, but only one miner is going to add it to the chain. And the idea is that adds some randomness so that you don't know who's actually going to be adding it to the chain. You also know that if they do add a chain, everyone's going to check it. It just it's basically kind of what secures the chain. So when I say we were mining it, we basically had a bunch of computer servers that we were just running constantly, processing
Mhm.
any Bitcoin transaction that came through. They would there's a section of a blockchain protocol called the mempool. The mempool has all pending transactions. So, they grab some pending transactions, throw them on block, and try to submit them to the chain. You know, if they're successful, we get paid. If they're not, we don't. And you're not successful every round. You can kind of do some stuff to increase your odds, and not really increase your odds. You can join a mining pool, which will basically allow you to mine with others and share the profits. But that's kind of roughly what we were doing. We had computer servers that were processing financial transactions and then trying to compute this math problem so that they could be the next one to add a block to the chain.
That's very interesting because I also read something about it, and it's just like I think it's more expensive now, the rigging machines, or they were expensive earlier as well. But like it was a great way to extract Bitcoin. Um, so yeah, let's move on to the next question from the audience.
Yep.
Oh, it's not a question; it's actually a like he's talking about how Bitcoin technology can be used. And yeah, it completely makes sense. It can make a transparent ledger system for compiling transactions. That's what it basically is used for. So that's why it's used for cryptocurrency as well. So it can track where it's moving from one node to the other, right? From one point to the other.
Correct. And a lot of and it's still a big thing. A lot of people come to the blockchain space, and there's still big use cases in that, in being anonymous and security and privacy. But on the other end, especially for businesses, one of the kind of better use cases, kind of the exact opposite, by the fact you have this transparent ledger. So if I'm trading goods with somebody, I can know exactly what goods they accessed, when they accessed it, that sort of thing. Very good for supply chain management, for example.
Yeah.
So in some use cases, it's very useful because it's a transparent ledger and you know exactly what happened when it happened. So it provides a more seamless way to interact with people.
Mhm. Right. So we have another question here. Who wants to talk about? She's a first year college student, so I see that you're already very excited to get into the space, and this is the enthusiasm that we want from everyone. And she asks, what is the roadmap of probably starting with blockchain development? Like that's what she means. How do you start, and where do you go from there?
Sure. So that kind of varies for everybody.
Mhm.
What I would say is just from a development cycle, I would probably stick with Ethereum at first. They have a bunch of documentation and kind of starter projects you can do, just kind of like a hello world, a little bit more complicated. So I'd probably, hop there, learn how to spin up your own miner, learn how to code in Solidity, which, we'll be doing here, but, basically start off some of your own projects just to learn it. Learn some how to code and that sort of thing. Once you do some starter projects, my best suggestion would be to probably find some open source projects and just start contributing. It's still a newer space, so it's kind of a bit like the Wild West, if you will. Not a whole lot of. There's definitely way more companies to get involved in, but a lot of them are very still early in the startup stage, or there's a few bigger ones, but it's you have a couple of options if you want to. There's not there's more intro blockchain jobs than there were to start with, but
Mhm.
it's still usually probably best to start just contributing to open source projects. That would be my suggestion.
Right. And if everyone is worrying about the roadmap, so this is the live stream that you started from. He's going to teach you how to make a smart contract. And here's where you started from. So what comes next will follow, but this is the starting point. So all of you stay tuned because it's coming like right now. Because so Lucas, first of all, the audience, I see that you have a lot of questions coming in, but we'll take it all after some time. First, I think we should start with the tutorial segment because that's what all of you are here for. But I'm certain that we'll come back to the questions and we'll answer all of them. Right. So let's start off with the tutorial. Um, so before starting off with it, like, could you tell us about what a smart contract actually is and what is it used for and how fruitful would it be to learn how to make one? Like, what is its utility?
Sure. Go ahead and jump into that. And just to get started, I am going to take a little bit of segue, just make sure we kind of all, at least at a high level, do have an understanding what a blockchain network is, but more importantly, how a smart contract fits into that.
Yeah.
So, the most simple form of blockchain network is a distributed ledger of computer servers. These computer servers, or miners as they're often called, are competing to maintain the network. There are different setups like proof of stake networks, proof of burn, proof of space that are different, but at the base level, you have a bunch of miners all competing to try to maintain this network. The very first case that came out was just a distributed ledger for financial transactions. We all know which one that one is, which is Bitcoin, where this allows you to send and receive financial payments without any third parties. Shortly
Hmm.
after this was, well, not shortly, but after this was done, people were continuing to develop on and build on it, and some people had suggestions. We're using this to send money. Why can't we upload code to this network and use this to actually run programs in a decentralized manner? Specifically, there was some open data fields in the Bitcoin transaction block. People were kind of like experimenting. What if we add code to this block, and then we could run this code? What if we add code to this kind of metadata field in the Bitcoin protocol? Use that to actually run a decentralized application. There wasn't much traction at the time for that. Blockchain networks by their kind of nature kind of evolve slowly. Typically, you have a bunch of stakeholders and miners you all have to get to agree to an update, so it just kind of goes slow. So the people talking about this kind of broke off and started developing their own network, specifically built to handle this idea of a decentralized application. So what they ended up doing was they developed their own set of networks, and these networks, they expanded that field I talked about and made it so that what would happen is you could write your own code, and the code they ended up making had to be, they ended up writing their language for it usually because there's some special things as part of a smart contract. They wrote their own code. Once you compile the code, you can load it to the transaction block, and then the network will assign it an address, and you can then access that code whenever. So basically, what a smart contract is it's code that's now permanently stored on the blockchain network. And the first one, and kind of the one we'll be going over today, and one of the bigger ones is the Ethereum network with their language Solidity, which is their smart contract language, and it's based on JavaScript. But there's a lot of others now too that are also good, and a lot of them have kind of unique use cases or capabilities like Polkadot, Tezos, Solana, Cardano, and Arweave. But we'll
Hmm.
be going over Ethereum and Solidity today.
Right.
So oh, go ahead.
No, you were saying something?
Oh yeah. So that's kind of what a smart contract is at a high level and how it fits in the blockchain network. It's just decentral. It's code stored on a blockchain network that's immutable and allows you to build trustless applications. How it then runs is that after you build and compile it and upload it to the network, anyone who wants to access it can send a message to that address to access the functions and run it. And then the way it kind of runs is that whenever you go to access it, it processes in the form of a transaction. So the state of the smart contract is always maintained.
Right.
Now, before I get into, let me know if time to go down to the next section. But before I get into any other thing, I did want to touch on a few specifics of the blockchain network and limitations specifically. Smart contracts are great. They allow you to build these new decentralized applications, or dApps as they're called. Kind of the great utility of this is you have a new trustless system without third parties. So I can deploy an app and it's up there forever. Anyone can interact with it, and you know it's always going to do the thing it says it does. So you can't exactly do this, but say I put a smart contract up that says, I want to sell apples. If you send me 1 Ethereum, if you ping that, it will always send you 1 apple.
Mhm.
But there are limitations of it. The biggest one is it's expensive. Every time you run the code, you have to remember from that earlier segment I said about how the network processes blocks. The entire network trying to run the block at the same time. So that means the larger the smart contract, the more data that is stored, the longer it takes, the exponentially more expensive it's going to be. So it's very important to always write optimized code. And after your kind of hello world, you do want to kind of understand how to make your code as cheap as possible. Otherwise, you may launch your contract and a month later it may no longer be runnable just because it's so expensive.
Mhm.
Additionally, the typical blockchain network cannot make API calls. If you can think of it too, if you had 20,000 nodes all processing your transaction and had an API call, you basically DDoS anyone you were trying to talk to. So instead, you typically have to rely on either the state of the smart contract, user inputted data, other data already on the blockchain, or you can use oracles, which are Oracle/special systems and plans that allow you to get data into the blockchain network. So have to make specific plans to get outside data. And then finally, this is part of the unique utilities of it, but also kind of limitation is the code's immutable. So like once you launch smart contract, it's up there forever. You can't take it down. So if there is a bug in it, um, you are going to have a lot of issues. So that's why it's very good to you always want to audit your code. You also probably likely want to always make sure that you do a good job making sure there's no bugs, but you also have a plan for any migration or future updates. A great
Mhm.
example of why would be the Dow Hack. I mentioned it earlier. It's something, if you want to get in the space, you should probably check it up. It's kind of part of the history of the space, and it kind of shows the importance of double checking your smart contracts. Long story short, when the first really big contract, somebody found a hack on it. And while it was fixed, it caused a lot of issues for the network and a lot of polarization. So that's just something great to read up on in your spare time. Not going to really go into it much further than that here.
Yeah, I mean, everyone can like just research about Dow Hack because it's so. He told me about it and I researched on it further, and it was something very interesting that everyone should read about it before starting on this journey, right? So I see still you have a lot of questions coming in because blockchain and Web3 is such an interesting concept. We get it, but we are going to feature them later and he's going to answer them. But first, let's just move to the tutorial segment because that's the most exciting part of the live stream. So we don't want to keep you away from it. And then we can start now, Lucas.
Sure, sounds good. I'm going to go ahead and share my screen.
Yeah.
Okay, share screen. Okay, there we go. All right, so to get started, now I'm going to be showing you how to, write a smart contract-based application. These things are also often called dApps, or decentralized applications. First things first, there is some installation steps. Not going to step through quite all of them because there's quite a few things to install, and some of them are pretty straightforward. But I will just give you some quick ones. Getting started off, I would advise downloading and install Ganache from the Truffle web suite. Truffle provides a lot of applications to help you out with blockchain development, specifically for Ethereum and Cordova. But Ganache in particular allows you to quickly fire up a Ethereum test network. It makes it really easy. It even pre-populates it with test accounts. For Ganache, you can just go to if you Google Truffle Suite, you can just go to their site and download and install it. I already have it installed on my setup, so you can see me launch it, but I won't be going through the installation steps for that. You should also installed Node.js. Not going to really cover that here. Assuming most people have Node.js experience, and if you don't, it's fairly easy to install. You can just go to their website. I will touch base on the next one, Web3. Web3 is a very popular blockchain library you can use to help you interact with the blockchain network. You use Node to install it, so I'll just go ahead and run it. Pretty simple installation, but just in case, you can just use a Node project manager tool to install it. So I'm just going to install it globally here. We'll say that it's what? Sorry, npm install web3-g.
You made a typo there.
Yeah. Oh, sorry. Yeah. English was not my specialty, but yeah, you can see it installing. So it's already installed. This will just take a minute, but pretty straightforward. And then the final tool you install won't actually run it, but it's very similar, would be Truffle as well. Truffle is also related to the Ganache. It's another tool provided by the Truffle Suite website. You just go npm install Truffle -g, and that will install that for you as well. I already have this installed on my computer, so it's not really it's not something I'm going to cover here. Mm-hmm. All right. Now that we have that set up, I'm going to show you how to start your project. Give me 1 second. I realize I'm in the wrong library. Okay, so to start your project, kind of mentioned Truffle and Ganache a few times. Truffle is particularly useful because they do a few things, but one of the things they do is they allow you to quickly initialize a kind of what's the term, boilerplate for a decentralized app. So in this case, we're going to run a Truffle unbox React. What this will do is basically it will create a decentralized boilerplate for a decentralized applications and Solidity-based smart contract with a React front end built in. So basically have a hello world set up for us to do that we can then expand on. It will have some simple contracts as well. While that's running, just to kind of dive a little bit more into Truffle, it can provide a lot of tools in addition to Ganache and this boilerplate it's providing. You can also use it to manage the lifestyle of your smart contracts. You may need to maintain them when they're on a blockchain network. It has testing frameworks for use, and additionally, it has a lot of different deployment and developer operation scripts. So we can see our project successful. So we're going to come over here to the actual project now. So this is what it just built. You can see a bunch of directories and some files here. So I'm just going to briefly step through them to let you know what we're kind of looking at. The client directory has access to the React application. It kind of pre-deployed for you. Has a place to deploy your node modules, has the place to deploy your build packages, has all the setup, and it has the source, which is the actual application itself. Something I'll touch base on real quick because we may not have time to come back to it. That Web3 library I mentioned earlier, if you do this on your own and you come here, you can see that library in action. You can see it right here. We call get Web3 to get an instance of the Web3. From there, you can get access to all the accounts that are currently signed in. So, basically you get access to your wallets here. You can see they're connecting to the Ethereum network. And you can also see here they're accessing a smart contract. So they've got access to a smart contract. They're setting the value to 5, and they're sending the transaction from account 0 from their wallet list. We'll try to come back here later, but depending on time, we may not be able to quite get back to this. It's a little bit of an extra thing if there's some spare time. Okay. Carrying on, you then have this contracts directory. This is where we will actually write and store our smart contracts. There's some very simple ones they deploy with you, just so you have some options. We will likely briefly look at one of these towards the end, but for the most part, they're just some very simple smart contracts. Nextly, you have the migrations folder. The migrations folder is actually what tells Truffle how to deploy your smart contract. So as I kind of mentioned, Truffle provides a lot of tools to handle deployment of your smart contracts. So this is how you can tell Truffle to actually, launch your smart contract onto a blockchain network. So in this case, you can see it's a pretty simple deployment. It just deploys the artifact, which is the actual smart contract itself. Finally, it provides a test suite, which is some simple tests to start off with. And then kind of last unique thing here is a Truffle Config file. This is what tells Truffle how to run. We will dig more into this file at the end, but you can see here I'm telling it where to put the compiled smart contracts. And just to touch base on this part, because this is a bit of an extra thing, you can see it's telling it to create a directory in the clients library we're just at for contracts. What it's building there is called an API file. It basically contains basically directions on what the different functions of smart contracts look like. So basically you can plug that into Web3, and Web3 then knows like what you're actually talking to. It's not just some random address on the Ethereum network or Cardano or Solana or Arweave. It directly tells you, hey, this is the data storage smart contract. This is the list of functions and the input it takes. So that's a briefly walking through the project. Now we're going to write some code for this. So coming to the contract piece,
There's a question that has come up. Somebody's asking which ID are you using?
Oh, on network ID? Yeah, so
No,
for the network ID, I'm assuming, tell me if I'm incorrect, can't see the question, but if you're talking about the ID on Truffle Config for the network, we'll be using the network ID for 1, or network ID of 1. That should sync up to one of the more modern versions of Ethereum. There's a lot of different IDs you can look at. We may come back to that at the very end if we have some extra time, but overall, for those a little bit less aware, you can, there's a lot of different blockchain networks out there. A lot of them are kind of based around Ethereum or based around Truffle. So you can actually specify which network you want to talk to here just by setting something called a network ID 1, or you can do 1000, and that will give you the a different blockchain network. So 1 may be Ethereum, 0 may be an older version of Ethereum. There's some test networks out there, and then there's also a lot of additional networks out there as well you can connect to.
yeah, that was an amazing insight, but the question was very,
Oh,
very basic. That was IDE. Which IDE are
oh,
you?
IDE. Sorry, I heard ID. IDE. I'm using Atom. I
Perfect.
kind of started development with Atom because back earlier in development cycle, there were not a whole lot of plugins to make developing in smart contracts easier, and Atom had a bunch of them pretty early, so I can have a nice, pretty color-coded smart contract. There's a lot more integrations now, so feel free to use whatever you want to use. I've just typically used Atom for smart contracts because they've always had available plugins for it.
Right.
Yeah,
So I think, yeah, Junaid, the video recording will be available, and I think we can start now.
sounds good. So starting off, I'm gonna write my new smart contract. I'm gonna call it DAO.sol. Let you know what we will be building today is called a DAO. It's a decentralized autonomous organization. It's a very popular kind of concept in the blockchain space, and the idea is you can, instead of having well, you probably still have one, but instead of managing an organization via contracts and trusting people, you can write down all the code to maintain an organization in a smart contract and convert that way. So you can have voting, you can have membership rights, you can determine who new members are through a DAO instead of other things, and that DAO can interact with others. So we're going to be building just a simple DAO. It won't be necessarily optimized, and there'll definitely be missing functions, but just designed to kind of give you a brief, or not brief, but give you an introduction into how to write smart contracts.
Right.
So starting off, we're going to first need to tell the smart contract what version of Solidity we're using. Solidity is still relatively new, so it kind of evolves pretty fast. So for that, you write pragma Solidity, and then you're going to write your version. So in this case, we're going to write version. We want to use some version of Solidity between 0.07 and 0.90. So this is basically telling the compiler that when you compile the smart contract, you need to have a version of Solidity that's equal to version 0.7 or less than equal to or greater than 0.7 or less than 0.9. Otherwise, it will throw an error. After that, we're actually going to declare our smart contract. So we're going to do write contract DAO, kind of similar to how our class would look. So we've now declared our smart contract. Going forward, kind of I mentioned, we're writing a DAO, so let's declare some more complex data types that may not be immediately available. Since we're writing an organization, let's have a DAO then that let's have a structure that will represent a member. So we're going to write struct member. Struct symbolizes that we're going to have a more complex data structure, and it's going to be called member. After that, let's declare some fields. So we're going to have UINT, which is unsigned integer. It's one of the common. It's can pretty commonly used for integer values. We're going to assign a weight, which will be the weight of the member's vote. Let's declare a Boolean value for voted, determine if this member has voted on a recent proposal, so we know they don't double vote.
Yeah.
Solidity contracts, since they're unique and everyone talking to Solidity has a Ethereum address, there's an address field for an address value. So to declare an address, we're going to call it delegate. This will simplify if they delegated their vote to someone else. Have another vote. This will actually represent what they voted on. We're going to have a proposal field that will list all different value or all different proposals they can vote on. Let's have one more address to actually store the member's address itself. And finally, we're going to have a location field that will just be used for a faster lookup time. Ideally, you want to have as few fields as possible. As I had mentioned, every additional field you store kind of vastly increases the cost for a smart contract system. So this isn't necessarily an optimized smart contract. I'm just trying to go over as much as I can to help you get started. Let's go ahead and declare one more structure. We'll call it our proposal field for anything you want your decentralized autonomous organization to vote on. In this case, we'll have a bytes32 name of the proposal. Real quick, Solidity and a lot of the smart contract languages have strings, and you can use strings. Usually they suggest to use strings for arbitrary length string values, specifically that are bigger than bytes32. The reason for that is, cost. Strings cost more than a bytes field. So if you have a relatively short string, you probably want to keep this as bytes32. Additionally, if the string is really short and you can fit it in 1 byte, you might just want to do a bytes1 because that will just save you a lot of money down the line. That is one very unique thing in kind of smart contracts. You really have to think about every line of code because it will pretty quickly add up in real world dollars for you. Now let's have another field called vote count, which will be the number of accumulated votes for a proposal. And then finally, the address. This is not a completely functional DAO, but the rough idea of this DAO is you can have a bunch of members in, you can collect money for the DAO, and then you can give proposals to fund stuff. So maybe it's a smart contract, maybe it's a person, but in this case, this will be the receiver of the funds. Okay, next I'm going to build a few kind of the equivalent of publicly available class variables here. That's kind of a way to think about them. So I'm going to do an address public. This will be the chairperson or the leader of the DAO. We're going to make it so this is just whoever creates it. But the idea is that smart contracts do keep track of state. So now we'll forever know who the owner is. Briefly to touch base on the public keyword you saw. There's several public keywords, but generally speaking, they tell you who can access it and what. Public functions are variables that can be used externally, internally. They're pretty much kind of a decent default if you're not quite sure who you want to access it. Additionally, anytime you use public for a variable, there's automatically a getter function created for it. There's 3 other kind of pretty widely used keywords here. One is external. External functions are, if you declare this external, and we will make one of these, they're only meant to be called by other contracts. So if you use the keyword external, you are not supposed to, and it's harder to call it within your function. It is possible, but it's far more convoluted, and it's not as efficient. There's also internal. The internal keyword basically says that the function and variables can only be called by the smart contract itself or smart contracts derived from it. So, you can basically have a smart contract network or have smart contracts that inherit portions of the smart contract. So internal restrictions to those. And then finally, there's private, and private functions and variables can only be used by the smart contract itself. So no derived smart contracts can even access it. Most stuff we're going to be in here is public just for simplicity, but we will have 1 or 2 external functions.
Right.
Going on. Going to declare a balance, so we'll know how much money is stored in the bow. And then we're going to declare a public number of members, just so we can keep track of how many members there are. Next, we're going to do something. We're basically going to generate what kind of is equivalent to a hash map. We're going to call it's going to be use the keyword mapping, which will map an address. Oh, sorry, typo. Address to a member object. Then we're going to call this a public member so that anyone can do a quick lookup to see or access a member of the network. And then finally, we're going to do 2 dynamically allocated arrays.
Mm-hmm.
Public proposals, member, public members list. So these are 2 dynamically allocated arrays. Like I said, this is not the most optimized version, but I want to show you as many data types as possible. Ideally, you probably just have this or the map. Now I'm going to get into one final function, and then after that, I'll pause for some questions for a minute.
Right.
We have everything set up.
Mm-hmm.
So we need a constructor value to actually construct and build a smart contract. In this case, we're going to take a bytes32 variable or array, and it will be proposal name, which will basically initialize with all the initial proposal list of the DAO. So you need to vote on stuff. You can initialize the DAO and initialize it with all the stuff proposal. You'll notice this keyword here, memory. Memory basically states that this is a temporary variable. What that means is that when the smart contract processes it, it will temporarily store this value in memory and process the transaction, but it won't process it, store it after that. So if you want to come back later and find out what happened or access this variable, it will not exist. You could instead name this storage, and the storage keyword basically says that we need to permanently keep this in the state and make it accessible to people. So, if you called this storage, you'd be able to access this later and see it later. The main reason to use memory versus storage is that it significantly lowers cost. The more data you store, the more expensive it is. So this saves us money long term. Next, let's set the chairperson that we declared earlier. Every function has access to the message object. That is, the message is because every function was actually called by a transaction. The message is that transaction that was called. So, and the message has all the fields. We won't touch base on all of them. We'll touch base on some of the main ones though. The main field you'll use pretty often, sender. That's the person who actually sent the transaction. So we're saying the person who created this DAO is going to be the chairperson. Now let's actually add them to the DAO. So we're going to declare member, memory, chairperson struct, and there's go ahead. Were you going to say something?
Yeah, I was going to point out the typo, but you found it.
No problem. Yeah, I think I'm going to be honest. I think you taking a pause there gave me a hint that I had a typo. Yeah, I will say while I'm typing this, I am going to be compiling from an already completed version of this project just to make sure that no typos leak through, prevent us from typing deploying. You can see here there are a few ways to initialize an object, but this is one way. The values I am putting in correspond to the order of the structure itself. And so you can just see I'm declaring a member variable. It's a pretty simple one. To let you know here, this address fields allows you to initialize address to a certain value. I'm doing 0. That's kind of the equivalent of the null address in Ethereum. It is an actual address, but it's a burner address. So no one actually owns it. And when I say burner, it's oftentimes used if you need to permanently get rid of Ethereum for any reason or something, you can send it to address 0. Carrying forward, let's now add this to the map so that we can pretty quickly find it. So in this case, we have that earlier address for chairperson. So we're going to set that equal to the chairperson struct. So now that is permanently stored. And then we're going to do members list.push, members chairperson. And then, so now we have this push to the array. And then finally, we're going to do a simple for loop. As I mentioned earlier, this is a JavaScript-based language. So if you're used to JavaScript, this should look pretty familiar to you.
Lucas, there's another typo being pointed out at line 32, and I see that people are following it really
Ah,
well. Right.
thank you. Yeah, appreciate that. Yeah, please point out typos. It isn't a big concern because we'll be compiling from something else, but want to avoid them. Proposals. So now we're going to push the back. I'm going to show you another way to initialize a function. So we did it the other way. You can also just actually declare the values themselves. You want to be a little bit more specific. So we're going to declare a name. This is specifically going to be the name value.
Mhm.
And then we're going to do vote count. No one's voting for this yet, so 0. For simplicity's sake, we're just going to make the receiver the message.sender in this case. Maybe not the greatest of proposals, but if we wanted to, we could pretty quickly expand this, and maybe we'll have some spare time, so that anyone can submit to this, or so that we can have a little bit more variety in the proposal list. And then finally, let's just keep our number of members set to 1 because we now have 1 member. And that's kind of our first constructor. So when we deploy the smart contract, this is the function that's going to be called first to kind of initialize everything.
Yep.
I'm going to pause here in case there are any questions before I dig into the next function.
There are a ton of questions, and if you have anything else regarding all the setup, you can just put it right away. And I'll start with one. Um, hmm. So the first question that we have here is, what is a burn address? If you could expand
What
more.
address?
Burn address.
Oh, okay. So it's a thing in the community. When you burn something, the idea is it's usually a cryptocurrency and you're getting rid of it permanently. There's some networks that are, the earlier way I described a blockchain network is called proof of work, where they compete for the network. The idea there's a network system called proof of burn, where to submit a block, you actually have to destroy your cryptocurrency. And then there's other reasons for doing it too. But generally speaking, a burn address is an unused address you send cryptocurrency to permanently get rid of it. You have to remember every token on the blockchain network's tracked, so you can't just you're not supposed to burn money, but if you destroy some type of currency, it's gone permanently. The way you do that in a blockchain network, something like Ethereum, is you can send it to an unused address. In this case, the 0 address is unused by anybody. So the address 00000, no one uses it. So if you send Ethereum there, the crypto is permanently gone. In this case, we're using it more as a null field, but if for some ever reason in your proposal you need a way to get rid of a cryptocurrency, you can find an address that's unused and just send cryptocurrency to it, and it's gone forever, basically. You can still see it is at that address, but there's no way to access it. So it's not probably something you'll be using regularly, but it is a terminology in the field.
So that's literally like burning money, but you're burning it in the form of tokens.
Correct. And like I said, it's not something used often, but there's
Mhm.
networks that actually run off of it. And there are some times you may need to burn something, or maybe part of your smart contract system. It can vary, but it is a thing.
Right. And we have one more question from Mohammed.
Yeah.
Is there a way to ensure that each address belongs to a single person?
Um, the network kind of takes care of that itself. Once you create your wallet or deploy your smart contract, its address is automatically owned by a single person. The one thing that can happen is that you could create a wallet that has multiple people own it. There's actually several open wallets, source wallets, that make this pretty easy. I think
Mhm.
Genosis has one specifically that I've used before that's nice, that will allow you to have an address that's controlled specifically by multiple people. So you could create this wallet and you could have 3 to 4 owners that vote on where the money goes. It's kind of like a DAO. Well, it is a DAO in some ways. But that's not the default. Someone has to kind of go out of their way to set that up. And then, while it's owned by multiple people, from the outside looking in, it looks like a single entity. So and in that case, it's kind of hard to tell. So it's not really possible to tell, but I would say is the default is like you're only interacting. The default is each wallet's owned by one person. And even if it's owned by multiple people, it's still you're only interacting with a single address. Does that answer the question?
Yeah, I think he does. It does, Mohammed. If you could let us know if it does answer the question, but I think it totally did. And for the third thing, we don't have a question, but we have something from Rishika Rawat, who says that this is so cool. More power to you, Lucas. So
Thanks.
she's totally supporting you, and then I think this gives you a lot of enthusiasm to go over the second part of the code. And yeah, okay. There's one more question actually. As you said, it's from Karan. As you said, every piece of code costs money. So, is there any tool out there that estimates the cost before you publish to the blockchain?
I believe there are, but I'm sorry, I don't have them memorized off the top of my head. Typically, what you can do outside of use tools is, as you'll see, we'll be deploying to a test network, and you can get an idea of the cost there. Yeah,
Right.
sorry, but I just don't have them memorized off the top of my head. It's also the environment runs pretty quickly, but you will see us test deploy to a network. And when we test deploy, I can show you the field that will kind of show you how much Ethereum it costs to deploy it. And then, we're going to do some transactions with the smart contract, and I can show you how much it costs. So I can't give you any automated tools to directly calculate the cost, but I can show you how to manually get an idea of the cost if that works.
Yeah, I mean, that would definitely work. And I think that completely answers his question. For the next questions, we'll come back to it later. I think it's time to move on to the second part. Um, so you can
Sounds
start.
sounds good. Okay, so for the next function, we declared our smart contract if it actually runs now deployed. So let's allow people to actually interact with it. Currently, we only have a single member who's the chairperson. So let's give people the ability to actually join the DAO. So we're going to declare a new function. We're going to call it join DAO. And a few things before we get really started into it. Before every Solidity function, they allow you to declare some keywords that will allow you to kind of optimize and set up your function better. So in this
Hmm.
case, kind of mentioned how we want to allow people to eventually send and receive Ethereum via proposals on this. So we need some Ethereum to start with. So in this case, we'll have our members to join, they'll have to contribute a certain number of the cryptocurrency. For a function to actually receive cryptocurrency, though, and for it not to send an error when people do it, you have to declare it payable. So this keyword basically tells you, hey, this is a smart contract function, but not only that, you have to send Ethereum to it to access it. And then we're also going to use a public keyword because, once again, anyone can access this function. Maybe decent place to look to actually change this to external, but for now we're going to keep it simple on public. Next thing we're going to do is declare the function require. Require kind of like work like an assert. Require checks to make sure the conditions are set before it returns before it actually proceeds. And if it doesn't set, it will cancel the transaction. One good thing, just to say from a general design perspective, usually want to do your requires as early as possible. The way to think about that is if you function does something to change the state of the smart contract and then it throws an error, or there's a requirement doesn't pass, it could potentially lead to issues. This is something they've been working on with Solidity versions, so it's not as bad as the past, but typically speaking, do all your checks first. In this case, we're going to say that we want anyone to come into the network test to send a equivalent of 200. And to let you know, this will be 200 Ethereum. However, this isn't necessarily 200. Basically, Ethereum can go way into the digits, and this isn't necessarily, actually 200 ETH. This may actually be a specific, depending on how you set it up, this is actually a different unit of it, but, not going to cover that today. Just roughly speaking, the message value sent here has to have a value of 200. And then should it not have, it's going to display an error message, correct amount,
Hmm.
not deposited. So we're going to make sure they actually send the money. If they did send it, they can now join the DAO. So we're going to declare a new member. In this case, I'm going to use another memory value. Don't really want to have to store and pay for storing this permanently. Since this is a temporary variable, going to declare another object. This is a little bit of repeat of what we just did. Also zero message sender, and then in this case, since we now know there's multiple people, will now say that this is member. We're declaring which member this is. Right, so new member has been declared. Also similar to before. I'm gonna just kind of like I kind of mentioned, do already have a working version of this. So to kind of be efficient with time, for stuff that's a repeat, I'm going to be kind of copying stuff from the existing one just to kind of avoid typing go quickly. But you can see here, I'm setting up my hash map so that the new message center will point to the new member, and then I'm adding this new member to the member list as well. Additionally, since I now have a new balance, I'm going to be adding the message.value to the balance. So, if you noticed, I'm not actually accessing the wallet of the DAO here. This smart contract already kind of has a wallet that can store value. So I just need to keep track of how much money is actually stored in it. And then we're not going to be able to go through it in this section, but then there's a separate standalone function that's built in to Solidity you can call to actually send Ethereum later. But you can see here, I'm keeping track of the balance. So don't actually need to store the Ethereum, but do need to keep track of the balance. And finally, let's, oh, that's in the wrong spot, sorry. Let's go ahead and iterate the number of members. And now we have our first contract. So, it allows people to join the DAO. It checks that they're sending money with their transaction. And then if they did, we add them to the DAO, update the balance, update the member list.
Right.
All right. I'm going to go through another function now. This function, people join, but, it's an organization. There could be different voting rights. So we're going to give, in this case, we're going to do just a simple version, and the chairperson will determine voting rights for each time you go to set a proposal vote. Probably more better ways to do this. There's something more complicated, but this is just designed to give you an idea of it. So in this case, we're going to pass in the member we want to update for the voting rights. I described there were different keywords in public. In this case, we don't want other smart contracts calling it. We know for a fact that only this will only be updated to external accounts. So we're going to declare this external. And now we have an external function. Now let's do a quick require. Were you going to say something?
No, go ahead.
We are checking to make sure it is the chairperson again. Then we are going to declare our message. Only chairperson can give right to vote. Then let's have another version. We probably don't want the chairperson giving the right to vote to multiple people, or giving, basically repeating this for somebody who's already voted or someone who's already given the right to vote. So if they've already voted, we're just basically gonna ignore it. Has already voted. I see there's a typo there. Hold on a second. And then, we now have two checks. Let's have a few other quick checks just to kind of get rid of some potential error-prone or edge cases. We're just checking to make sure that this person actually has a voting weight. So, they've actually, or they don't have a voting weight, meaning they've not been added in for this proposal yet. We're making sure they actually exist. Now we have our member address. So now we're actually going to do a hash map lookup for the first time. Or, is it? Yeah, not for the... never mind. So we're going to quickly look up our member from the member hash map, and then we're going to set its weight to 1, meaning that this person can now vote on the current proposal list. And that will cover this this function. So, only the chairperson can access it. They can only use it on people who haven't voted yet. And what they basically go through is make their voting weight 1. So they can now actually vote on whatever proposal comes next. Okay. I'm now going to pause for any questions before I get into a few other functions.
Right. So we have already seen 2 questions of join DAO and then give right to vote. So if you have any questions for these 2 segments, you can put it in the comment section below and he'll answer. So we have one question. It is Sachin asks, in join DAO function, will it consume ether when I mention payable or not? how can I restrict amount sent to function call?
So A, if you do not declare payable, so one thing I'll say is, functions cut gas. It's possible that with some external and getter functions, especially if they're locally based, they'll potentially be free. If you're doing a lookup and you're running your private Ethereum node, it could be very cheap to virtually free. But in general, every smart contract does cost money because, there are miners processing it, and those are called gas fees. So when you send Ethereum, when you activate a contract, some of your Ethereum or whatever cryptocurrency you're using gets used to pay the miner, and that's gas fees. And gas fees are what makes your smart contract expensive. However, I did want to say that's there. What you're asking about is people sending Ethereum to it. If you don't put payable, they won't really be able to send Ethereum to your smart contract. And then additionally, the to restrict the type of values you can see, you can make sure that it's, in this case, message at value 200. So, if it's not in the value of 200, it won't receive. If we wanted to say make this wider, we could say, greater than equal to 200. And then we also want it to be, less than or equal to 1000. So we could actually give them a range to send. And then here, the value will go along with it. But that's roughly how you would do it. When an error is thrown like this, it will end up reverting back to its previous state. So in this case, that's how you would handle it. If the transaction doesn't go through, the value doesn't actually go through.
Right. So I think it answered your question, Sachin, and looking forward to more questions from you. Um, yes, you can watch the recording. It will be on YouTube, LinkedIn, wherever you are tuning in from. You can watch it anytime you want. And we also have one more question from Sachin, who is very excited about the live stream. Sachin asks, does transaction cost depends on join DAO's content and function arguments also?
Great question. And it does. I'd say the two kind of biggest things will depend on, the general size of the function, but kind of more than that, but it leads into it, is the time it takes to run the function and the amount of data stored in the function. So you see in join DAO, here we're declaring this new member, so it will cost money, but it's temporary. It's not going to be stored after the function call, so it's going to be cheaper. But if we made this that keyword storage I mentioned, we'll have at least sorry, why am I blanking on? I'm blanking on how storage is spelled. Definitely was a math person. Oh, there we go. If we declare storage, it's going to be more expensive. So the actual amount of data stored in the transaction matters, and then we will get to this more in a second, but additionally, the time it takes to run the transaction matters. So in this case, it's O of one time, but let's say we add in a for loop or while loop, that could significantly up the cost. In fact, it is a potential, adding in for and while loops especially while loops, can potentially be dangerous because I'll get into this actually specific example in a minute. But let's say I had a while loop that allowed, you can see you can delegate votes. Let's say I ended up having a lot of people delegate to each other. And let's say the DAO got massive and I had 20,000 people, and each one of the member of the 20,000 delegated to the next, and you had this long chain of 20,000 people delegating it, and I try to go through that. That could actually make the smart contract so expensive that it's not possible to run. There's somewhat of you can kind of think of it that each block kind of has a max gas limit. So if your transaction causes so much gas, you could actually, and it becomes so time-consuming expensive, your smart contract may actually break and not be able to run. Yes, the way you write the smart contract matters a lot. Each into a function will add to the cost. Overall, you want to keep them small, and you also want to try to make sure they run efficiently as possible. While loops can be dangerous, along with for loops.
Right. So there's another question, but we'll take it later. I think we should move on to the third segment now. So we will answer your question, but after some time.
All right, sounds good. Adam, how are we doing on time? I just want to check to kind of let everyone know. My plan is to probably go through one or two more questions, and then after that, I'm going to one or two more functions, and after that, I'm going to just bring over the rest of the code and just quickly step through it so we can get to actually deploying it. Does that work, Sanskar?
Yeah, yeah. I mean, like we are getting a feel of how you are working around the functions. So if you just go through it, I think it'll be enough. But yeah, you can do the third part now.
All right, sounds
That
good.
should be.
So for the rest of them, I'm going to just kind of copy and paste them over and just step through them just to be efficient with time. All right, so we're going to come up. You see I pasted some code. So previously, we gave people the right to vote and join the DAO. The next function will be get members. This is our first thing that really returns a value. And you can see there's a new keyword here too called view. View functions, there's two things you can put in it for a view there. A view function basically says that this will not modify the state. What that means is view functions are typically cheaper and easier to and quicker to run. So if you declare the keyword view, that just means that nothing in here is actually going to be modified. It's basically just a special getter function. There is another thing you can use instead of view called pure, and pure is a subset of view functions. And in pure functions, basically it doesn't change the state, but it also doesn't access any data. It just uses the data from the actual function call. So you can kind of think of if you had some say you had a function called calculator addition that will just calculate the two input values you put in to the constructor or the function. That would be a pure function because you're not accessing any variables. It only uses the values you inputted. So this is a view function now. Nextly, when you return values, you want to also declare what you return. There's a few different ways to do this. This is kind of the first way. In this case, we're saying this returns an address array. It's going to return addresses, an array of all the members. And then this is temporary. This is another memory object. We don't really need to store this value. This is just someone basically checking for their own sanity. What is the current member list? Going through here, you can see that we declare our array. One kind of common, just best practice is to use an underscore in the front for return values. So, and then we set that equal to the new address array. It's best for return values if they're not dynamically sized. So in this case, we're setting it to the number of members. After that, simple for loop, go through, add them all to the new member list, and then return the member list.
Right.
Yep. Next one, I kind of mentioned delegate. Want to go through this one quickly because you can see this dangerous while loop I mentioned. Were you going to say something?
No, go ahead.
Okay. You can see we have a delegate. You're declaring who you're going to delegate to. I don't want any internal functions calling this, so it's external. In this case, you can see I'm using the storage keyword for the first time. In this case, I'm declaring member storage sender, and I'm saving the sender of it. The reason I would use this here, if you can think about it, if you were running a business or an organization with your friends for class, you may want, and you decide to delegate, you may want to have a record of that. Like you may want to have, something could go wrong, and you may want to go back and just see, okay, who delegated, who was the person who sent in the delegate, and who was the actual person delegated, so you can quickly go back and check. Here we're making sure there's nothing kind of funky going on. The sender hasn't already voted and trying to delegate. We're also making sure they aren't trying to do weird and delegate to themselves. Here you can see this while loop we wrote. In this case, the while loop is checking to see, if we have a delegate chain, because I could delegate to someone, we're delegated to someone else, so we need to make sure you're delegating to the proper person. This could be dangerous, though, if you have a very long delegate loop, as it could potentially run long enough to increase your gas. We're not dealing with that here, but you will likely, in an optimized version, you'll likely want to do something here to make sure you can't have delegate loops or delegate chains of delegates that are too long, because that could actually break your smart contract and prevent it from running. Additionally, we're checking here to make sure there are no loops. If a really long while loop is bad, you can guess that a infinite loop is, very bad. So we're going to do a quick check to make sure there are no loops in it. After that, pretty straightforward. We're making sure the person who has a delegate can't vote anymore. Actually setting the delegate. We're also storing for future transactions who the delegate was. After that, if the delegate has voted, we're getting who they voted for and incrementing the vote count. And if they haven't voted, we're just increasing their voting weight. So when they do go to vote, they vote for everybody.
Okay.
Next, we have our actual vote. Pretty simple. You plug in your proposal, also external. We're not allowing other smart contracts to vote here. We are using the storage keyword because we want to specify, we want to keep track of, who actually sent this in or what member did this. We're making sure they actually have the right to vote here. Also making sure they haven't voted. Then we have them vote, so we're going to set the vote equal to true. I think there's a, oh yeah, no, there's not. So then we're going to say who they're voting for. So we're setting the vote to the proposal, and then we're incrementing the vote count. Relatively simple one. This is an interesting one. Here we're computing the vote. So the thing to remember about smart contracts and when designing them is they're not running all the time. When you deploy a smart contract, it isn't on a server that's kind of constantly spinning and waiting or has some background thing to update things. You have to, access a smart contract to run. So sometimes you have Oracle, sometimes you have a designated member, sometimes it just, when you have a function and you call it, it will trigger other processes to keep the smart contract up to date. But, in this case, we don't have it built in, but, you have proposals there and you're running a DAO. You'll probably have an agreement outside of it that, after a week of voting on proposals, we're going to calculate the winner. You can have that hard set. There are time-related values, and within the message.sender and several other things, it's possible to access things like the timestamp. You can also access stuff like the current cost of gas fees for the block. There's a lot of different values you can access from the actual blockchain network itself. So you can access timestamp to basically say, next time any function runs, if it's above this timestamp, we're also going to calculate the winner. We're not doing that here for time's sake. In this case, anyone who comes in can basically trigger the winner vote. Probably not ideal. We probably would want a requirement to restrict it to the number of members, but whenever we're ready, the chairperson or anyone can come through, call the winning proposals, and then that will calculate who wins and return the winning proposal number. As you can see here, this is also a public view. One thing I want to point out is this return is slightly different from the other one. One other way to declare it too is you don't need to necessarily say memory or storage. You could actually declare your proposal here itself. So you can see I declare winning proposal here. Go through, I'm not going to really step through that heavily, but you can see, go through all the proposals. If it's bigger than the current vote count for the proposal, I store that one, and I store that in the winning proposal, and I don't actually have to declare it. And I also don't have to return it because the function already knows to return whatever is stored here. Going through, getting close to the end. You can see here too, if you want to just see who won, you can do something similar. You can see here I'm actually causing an internal function. I didn't declare external here, I declared public, so we can actually call functions from here. So you can see to get the winner.name, I call a proposal, so get the winning proposal, then go in proposals, and then I get the name. Last function here, this is just to allow you to kind of reuse this for a DAO. Not really keeping track of proposals name, but this is pretty similar to the constructor. Not going to go through everything, but it pretty much just clears and resets everything. The one kind of thing that I want to call out here is, though, on line 171, I use the word delete with proposals. You can use delete to basically clear arrays. So when I say delete proposals, that reinitializes the array to be empty. The rest of this function will just go through, it will add in a new proposal list, and then it will also reset all the members so that they can vote again. That's our smart contract. It's not optimized. There's definitely a lot of stuff that could be added and extended on. We don't actually send the ether. As I mentioned, there's some functions you can call that will, there's some built-in function facility you can call to actually send ether. And there's a lot of different stuff we can add to it, but that's your first smart contract in a nutshell.
Right. So we went through a lot of functions, and I am pretty sure you must have some questions. So drop in your questions and then we'll answer it right now. Right. Okay. So one interesting question. What is the difference between variable names with or without the underscore attached?
There's not a whole lot of difference. To my knowledge, I will say Solidity has gone through a lot of updates. However, it's much more stable than it was a couple of years ago. or 3 to 4 years ago. But in general, it's just more of a coding standard, if you will. The underscore attached helps to just quickly determine from a coding style standpoint what the variable's for.
Right. There's another question. Is the timestamp depending on the node time zone?
Um, that is a good question, but it is not. The timestamp's built in to the Ethereum contract. It is. There are date variables of values you can do. You can actually declare something like week, week start. So you can keep track of weeks and dates yourself. However, the actual timestamp on the Ethereum contract is in milliseconds and is tied to when the Ethereum network started, or whatever blockchain network you have started.
Right. So I think those were it. And I think we can move to the deployment now. If you have any further questions, you can drop in. And then after the deployment, maybe we'll be able to answer them.
All right. Sounds good. I'm going to go to deployment. Going to come back to truffle.config section real quick. Going to just quickly update it. You're going to see not a lot has changed here, but to kind of briefly go through it again, there's a lot of different things you can do with this. Once you get started, the truffle config is probably something you're going to look through. But you can see here our compiled and contracts and our instructions for React or other networks to interact with the contracts will be stored here. The network we're going to be accessing will be accessible from our local port 48545. And then specifically, I'm going to be telling Truffle what version to use, which is version 0.7 or above. Going through here now, I'm going to now show you how to actually start Ganache. So didn't go through the instructions for this, but I'm deploying Ganache now. If you've not noticed, Truffle and Ganache like to name things after mushroom and mushroom-based products. This is the create a workspace session. You can see you can do Corda or Ethereum very quickly. So just going to quick start an Ethereum network. You can see now we have a deployable Ethereum network. I just want to say very jealous of everyone starting now who has this. Way, way harder to do before Ganache existed. But you can see it deployed an initial Ethereum network. You can see the current block is 0 because it's my own testnet. You can see what the gas price is, limit, what fork or version it's on, network ID, all that sort of thing. Very quick. It usually defaults in the second one. You can see it's auto mining. Most importantly, you can see it actually has all these test default accounts I have access to. So I don't even have to create accounts. It gave me 10 that all have 100 Ether. Really great for testing purposes. A lot of other things you can dig into here. You got logs, the blocks itself. You can see transactions going through. You can access smart contracts. Not going to touch things, but this is a really great tool. Really advise using it. Going forward, gonna now go back to those migration files I mentioned because they need to Ganache and Truffle need to know how to deploy our smart contract. So we're gonna deploy a new smart contract, or not smart contract. We're going to deploy a new migration file. We are gonna call it Dow underscore contracts.js. It is not gonna be that different from the previous ones. To let you know, the artifacts basically generates our smart contract artifact and sets it up for Truffle to deploy it. Nothing too big right here. So, we get our DAO. Now we're going to create our module to exports. And that is going to be a new function. The deployer is the Truffle API that will it's basically the API interface for Truffle for what we'll actually deploy it. It's going to do deployer.deploy DAO. As you can see, this is so far similar to the previous ones, but one difference, if you remember, is our smart contract had that initial field. So if your smart contract needs to take in arguments, all of the arguments after your initial smart contract will be those arguments. In this case, you only have one, and it's an array of bytes 32. Just to let you know, the arguments are usually, especially for bytes, are taking string form. So we're just declaring the initial string right here. And that will be
Right.
our migration file. I realized I forgot to mention one small thing from the previous section, so forgive me. I did want to touch base on the migration smart contract. There was one more thing I wanted to briefly show you. I'll only take a few seconds. Sorry about this. You see here, there's another function with a modifier keyword. This is unique as it allows you to modify and basically run functions ahead of time. For example, you saw that previously I had a bunch of functions checking to make sure the message.sender was a chairperson. What you can see here is this person checks if message.sender is the owner of the network. So you could change this to chairperson easily. The underscore basic here means basically, if this is true, you keep running. If not, you return false. And then what you can do is you can put this keyword here in front of your function. So now every time set completed runs, this modifier function will actually run first and run it for you. So it's a clean and easier and better way to do, if you have something that needs to be done a lot to each function, this is a way to pretty easily break it out. Sorry for that, going to come back through. Also, real quick, just from a naming standard, Truffle likes to kind of label the migrations, number them, say what it does, and then it in smart contracts. That way, because when Truffle goes through, it reads them sequentially. So now it's going to run initial migration first, then deploy contracts and Dow contracts. And like I said, I personally have not, most of the migration files I run are relatively simple, but you can do a lot of fun stuff here.
Yeah.
All right, going forward, we have our migration file. We're now actually going to run it. I will say here, I'm not actually running what I'm writing here. I have a pre-built version of this that will be publicly available on GitHub in the next couple of days. And we'll be going there to actually run it. Let's see the application. Okay, so we're now in the application itself. This is pretty much everything we just written at that parent directory. First thing we're going to do is run Truffle in the developer environment. So you can see it's now running. It is now in the developer environment. You can also see, since in the development environment and it was talking to Ganesh, it actually already has preloaded my accounts. And you can see my private keys. As an FYI, this is the test networks. These are randomly generated. This doesn't matter. Never give out your private keys. That's how you end up in a very bad situation. But you can see we're now in the Truffle environment. So now we're going to compile our smart contracts. This will actually build them for us. It will deploy those ABI files I mentioned from there. So in truffle.compile. In this case, everything's up to date, but it's still going to kind of run through everything. Truffle will redeploy smart contracts if they change. One thing to mention is if you don't specifically have a plan to migrate your smart contract and you need to redeploy it, your new smart contract won't have any of the old data. So usually you want to have a migration plan built in for any permanent smart contract. One thing I want to just also show briefly is now that it's compiled, I'm going to show you just kind of briefly, if I get it real quick, what the migration file, what that ABI file I mentioned previously kind of looks like. Give me 1 second. Just break it up. Sorry, give me 1 second here. So if you see here, I ran that previous function. I'm going to come in now. The build file is right here. This is what the ABI file and what was generated by it. You can see it has a contract name. It has a thing called ABI, and that what tells Web3 and anyone talking to the blockchain, this is what it actually tells you your blockchain smart contract looks like. It tells you the inputs, the outputs, that sort of thing. You'll need to store this if you want to interact with a Web3 library that we previously mentioned. Like right here. You can see here it actually gets the smart contracts. You will need that compiled smart contract to actually access it. All right, coming back. So going forward, we compiled it. Now we actually need to deploy it to the chain. So we're going to run the migrate command. This will migrate it to the test network we deployed. It's compiling them again. everything's up to date. It's still going to redeploy them for me because this is the first time it's deploying it. And you can see it deployed all three. Earlier, it was asked if there are automated tools to see how much it costs. There are tools. Ganache will help you with that. Just don't have them all memorized at the top of my head. I do believe actually now the Ganache, you can actually look at the transactions that went through. But, even looking here, you can get the total cost. You can get the total deployments. And then here you can see, what block it was added in. You can see the actual contract address number. You can see the timestamp. You can see the account it's associated with. You can also see your own balance. You can see how much it cost. You can see the gas price in GWEY, which is basically, it's kind of the standard amount of gas used, and it's not like a single ether. But yeah, and let's just see here. You can see here a block was mined. You can see the amount of gas used. You can see no transactions were called, but you can actually see the transact block itself. Additionally, we could hook up Truffle projects here for you to see. I'm not going to cover that in this intro, but once again, Ganache is a great tool to start off with. Now that it's deployed, as I kind of showed over here, we do have a React code we can walk through. However, I'm going to basically right now just call some simple functions from the Truffle command line to show you how to actually interact with your smart contract. One thing I will touch base on quickly, you should look through this React app. Very specifically, they show you how to actually connect with Web3 to a network. You can see they get the network ID, they get the simple storage contract they deployed, and grab the instance. And then you can see down here how they can interact with it with Web3. Coming back to Truffle, we're now going to actually access the smart contract. So this will be similar to the React app. We're going to get an instance of the smart contract.
Hey Lucas, just a heads up, like we are almost on time, so probably just one or two functions and then maybe we
Sounds
can
good.
move.
That's exactly what I had planned. I'm just going to copy and paste this then to avoid typos. So you can see up here, we got the member list from our instance. Sorry. Oh, so now, what? Okay, let me just try this. All right. Okay, let me try this again then. Oh, instance has already been declared. Let us try this again. Member has already been declared. Okay, then why aren't you? Sorry about this. This is the great thing about live streams.
Yeah, I mean, that always happens with code.
I'm not. Okay, this is a bit random. This has not happened before. I actually did this last night. I'm going to come up here instead then and just see then if I can just grab that and just walk you through it.
Right.
I'm not quite sure why it's not. Sorry about this. 1 second. I believe this is the. Here we go. So I'm going to walk through here because this is where I accessed it from last night. I don't quite know what the issue with Truffle. Sorry, that's the fun thing about live streaming. So you can see here I call let members equal to instant.get members. That was that function I wrote earlier. You can see when I call it, it's this address, which if we go back up to when we deployed Truffle, you'll see that it's this address right here. So it's the first address in there, and that's the chairperson. So coming back down, really, it would have been very nice if that would have run correctly. Okay, this is making it a little bit more confusing. Okay, here we go. You can additionally see the transaction that was called here. So you can see the transaction hash. You can see the gas used to access it. That was asked earlier. So we're going to do one final thing. We're going to join the DAO. So we're going to call instance.join DAO. In this case, what you're passing into join DAO is the actual transaction. There were no arguments to join DAO, so we're just going to put from accounts to. So we're going to add in the second account in our wallet. I'm going to set the value to 200. We press enter. I'm also going to actually try running this in a second, but you see we get the transaction hash, and then we get the receipt, which gives us the hash, gives us the block it's on, gives us the block hash and it also tells us the actual gas used by the function. So this is how you can test it permanently. And then when we call instance.getMembers again, you'll see that this was added in. I'm going to
Right.
also just try running this because it would be great if we could see it. And yeah, it's not seeming to like me right now, so I don't really know what's going on there. That's disappointing, but that's live streams.
That's
Um,
okay.
yep,
See the output, so it's completely all right.
yep. And one last thing, not going to run through it, but for those of you interested in running it live, to do that, you would go to your Truffle config file. Let me find it. You would go to your Truffle config file, and this is roughly what it would look like. You would want to declare your network live. You'd specify a network ID of 1 or your live network. You would change the port name and specify the host. And the one important thing too is you'll want to use something beyond Ganache. You'll need to set up your own client for the blockchain network. For Ethereum, you'd want to use Go Ethereum or C++ Ethereum. And then finally, when you start Truffle, I'm going to exit out. You would run Truffle migrate network live so it knows it's a live thing. And then it's, there's no actual Ethereum client running in the back end, so that's not going to run. That's probably going to error out. But, that's it for the demo.
Right. So we have some questions. I think we can just answer them and then we can be done with the live stream. So just you know what? Let's just take like one or two questions. First one is right. How to deploy the same contract in other test networks? Will it work in other platform networks like Solana or BSC test network?
It really depends. And give me 1 second. My laptop is apparently not charging. Okay, there, it's fixed. Yeah, it was apparent. This got the error message is about to die. That would have been unfortunate.
Yeah.
Um, it really depends. Off the top of my head, it depends on what contract system they're using. If they're using a Solidity-based contract, a lot of them do. Don't have on top of my head which each network uses. You would probably need a different tool than Truffle or Truffle does allow you to actually access a lot of smart contracts. Ganache itself just doesn't only has Ethereum and Corda technically.
Mhm.
But you could going back to that network config ID. If you want to deploy to a different network, you can use that. There are different networks on them. I'm trying to remember what some different ones are. For example, if you do network 3 or 4, that's the Robson and Rigby test network. If you did network ID of 10, that's Quorum, which is JP Morgan's network. But outside of that, if there's a Solidity smart contract, even if that itself doesn't work, you still deploy it. If it's not a Solidity-based smart contract, some do JavaScript. I know Tezos has their own smart contract language. You will just have to rewrite it, but a lot of the same rules apply. So, there'll be different keywords, different those sort of things. But, in general, you still want to keep it small. You still want to store as little data as possible. Really want to be careful with for while loops and remember that it all costs money. So a lot of the same standards will apply, but if it's different language, it's a different language.
Right. And one more insight from Daniel, who says if you want cross-chain network, you can try Morales. Like, have you worked with Morales before?
I have not specifically. I believe I used, I want to say Polkadot is what I've used historically, but a lot of the projects I built tend to be on one chain, or they may use multiple chains, but not like a cross-chain network. But cross-chain compatibility is a big thing. Morales, along with I want to say Polkadot or Cosmos, I think is the cross-chain one. I want to say it's Cosmos. Don't quote me on that, but there are a lot of cross-chain blockchain networks that are specifically designed to allow you to build apps across different chains, because you may have an asset on one chain and you want to exchange it for an asset on a different chain. There are tools you can use to accomplish that.
Right. So, well, I think that's it. And you have posted the code on your GitHub, right? I think this is
Um,
the link.
yeah, that is a link you can use. I will say I made a few changes recently to clean it up. So I will be posting an updated version in the next couple of days. I have a few things going on, but you know, within a week, there'll be an updated version of this, likely to a couple of days.
Right. But the basic
Yeah, the
code they
basic
can.
stuff's already up there. So if you want to go check, go ahead. There'll just be some cleanliness and some additional notes and learnings.
Right. So I think that's it. If all of you had fun learning, you can always come back to this video, rewatch it again, learn more about it. And I hope you are going to start in your blockchain development journey and become really cool developers, right? Lucas, you have anything to say?
Uh, no, just welcome to the space if this is new, and if you're not new, glad, thank you for watching, and glad hopefully you I showed something useful. It's a very rapidly developing space, so please get involved. There's a lot of great open source projects that specifically need contributors.
Right. And there were a lot of people asking for like if we'll do more stuff like this. So now that we have done one, and if you all really loved it, then we can probably call Lucas again, or we'll have someone else. But we want to get into the space further, right? And Lucas is always there. You can connect with him. What format would you prefer? Like LinkedIn?
I'm open. If you want to specifically connect to me and talk to me, LinkedIn's probably the best place to start. If you kind of just want to follow what I'm doing, I'm on most social media platforms. I'm on Twitter. Well, from a tech perspective, it's probably best to do LinkedIn followed by Twitter. But I'm in a lot of spots, so not hard to follow. I'd say start with LinkedIn and Twitter, and we can go from there.
Right. So, yes, you can follow him on LinkedIn and Twitter. And that's it from us. We hope you had fun and we hope you learned a lot. So, yep.